Recording in progress.
Hi everyone, welcome to the session 4B on natural language processing. This session will be led by Dr. Sugandhima Vidanachi. She is a senior lecturer at the Department of Computer Science, and she received her Bachelor of Science in Computer Science degree from the University of Colombo School of Computing, Sri Lanka, and she went on to do her PhD in computer engineering from the University of Kerala in Sri Lanka. She also acts as a visiting lecturer, visiting academic of the University of Southampton, United Kingdom. Her current research is focused on machine learning, hardware acceleration applications using FPGA, bioinformatics, and cybersecurity. Without waiting any further, I would like to invite her to lead this session.
Thank you, Shavindra. Good afternoon, everyone. I warmly welcome you all to the session 4B on natural language processing. There are 5 presentations in this session, including 3 full paper presentations and 1 post presentation. So the first paper presentation is paper ID 3, Sinhala Natural Language Interface for Querying Databases Using Natural Language Processing. So this paper has been authored by Dunisha Suloshini and Qasim Farooq. And the presenter is Dunisha Suloshini, who is a student of Informatics Institute of Technology, IIT, affiliated with the University of Westminster. The author has implemented a Sinhala natural language interface for querying databases using natural language processing for the final year individual project, and also presented the work in the competitions such as Cutting Edge IIT in 2021. So let us present the research work of Dunisha and Qasim. Over to you, Dunisha.
Sinhala natural language sentences to database queries. Before proceeding with the project demo, let me give you a quick introduction to the problem domain and real-world scenario behind the Sql Finder. Data is the heart of the decision-making process in every business, every organization, every government offices. But at the same time, working with data stored in the databases is very time-consuming and requires special technical skills like SQL. Mainly, the structured query language is used to communicate with relational databases. So, it is an identical problem that the non-technical people like project managers, business analysts, call center
Shavindra, I can't hear you. I can't hear the presentation.
Yeah, I think there is some connection issue. Presentation.
Shavindra, can you replay the recording?
The Fudanomachi please wait a few minutes. We are handling Fudanomachi. I think there's a connection issue. Am I audible?
I can't hear you as well.
Okay. Let me check. There's a small technical issue from our end. I think we might have waited few minutes.
This is the project demo of Sql Finder, an automated system which maps Sinhala natural language sentences to database queries. Before proceeding with the project demo, let me give you a quick introduction to the problem domain and real-world scenario behind the Sql Finder. Data is the heart of the decision-making process in every business, every organization, every government offices. But at the same time, working with data stored in the databases is very time-consuming and requires special technical skills like SQL. Mainly, the structured query language is used to communicate with relational databases. So, it is an identical problem that the non-technical people like managers, business analysts, call center operators, receptionists are facing difficulties while retrieving data from the databases. Basically, Sinhala is spoken mostly in Sri Lanka, and a large number of e-governance applications use databases where all the records stored in Sinhala. For example, Election Commission of Sri Lanka, Excise Department of Sri Lanka, State Timber Corporation, the State Ministry of Livestock, Farm Promotion and Dairy and Egg-related industries. In Sri Lanka, the literacy of English language is very low because the native language of the people is Sinhala, who constitute nearly 74% of Sri Lanka's population, which equals 13 million people. So that the requirement of Sinhala language in contrast to the English language is at a high level. A considerable amount of e-governance applications in Sri Lanka use databases. Therefore, to manipulate data from such database applications easily, non-technical users who are more confident with the Sinhala language need a solution to agree with a simple sentence in Sinhala and generate a valid SQL query. Based on this scenario, I developed Sql Finder using intermediate represent language-based approach. The algorithm will contain a lexicon-based architecture for the retrieval of required information in the translation of Sinhala query into formal query. Rich Picture conceptualizes the process by dividing it into subcomponents like linguistic component and database component. Initially, the user inserted Sinhala natural language query goes to the linguistic component, splitting the sentence into tokens, lemmatization, which means finding the root word, semantic analysis, classifying elements, generating the intermediate logical query is the flow of the linguistic module. After that, intermediate logical query will pass to the database component. To retrieve the final results that requested by the user, the intermediate query has to be transformed into SQL. Mainly, this transformation performed by the system's query generator by mapping the intermediate query with database information. Finally, query executor performs the generated query on database and fetch results. Mainly, SQL Finder consists of four major modules. The first one is Web Interface, which is simple and developed using React.js. The second one is Lexicon Generator module, which extracts all the metadata from the database and write them into a lexicon. The third module is Query Generator module, which processes the natural language query and generate intermediate query. Further, it transforms the intermediate query into SQL query. The final one is Query Executor module, which executes the SQL query and fetch results from the database. The proposed solution uses the three-tier architecture pattern, including the data access tier at the base, the application tier in the middle, and the presentation tier in the top. The the user inserting single natural language query will go to linguistic model of the system. First, the sentence will split into tokens. Then the tokens words will be normalized with their root words. After all the tokens have been normalized, the tagging of the type of every token will be done by use of a single lexicon. Here the tokens will be tagged whether it is a table name, column name, command or condition operator. Then all the tag words will be mapped. Now we have relevant requirements to generate a SQL query. All the found components will be merged to generate a query. Lastly, user will be view the query and able to execute it. Now we will see the workflow of the implemented algorithm of SQL Finder. You can see I have taken a single natural language query as වයස 21ට වැඩි ළමයින්ගේ නම් ලබා දෙන්න. Initially, SQL Finder will split this sentence into tokens, and that tokens are වයස 21ට වැඩි ළමයින්ගේ නම් ලබා දෙන්න. After that, system will normalize the tokens with stop words. Here the word ළමයින්ගේ has normalized to ළමයා and නම් has been tokenized to නම. So these are known as root words. Then the process of removing unwanted words will happen. Here the letter T has categorized as unwanted word. Afterwards, two types of mapping will happen. First one is semantic mapping and the second one is mapping of SQL components. Finally, the SQL query will be generated as select name from student where age greater than 21. Now I am move on to the demonstration of SQL Finder. Now let's move on to the implementation of the NAV model. This class shows the process of identify the table names and column names itself by the system. Get db metadata dictionary function will return a Python dictionary which holds a key and value. All the table names, column names will be stored in the Python dictionary, with the table name as the key of the dictionary. And the lexical generator class would iterate by the key in the dictionary throughout the process. Singular word, root word, SQL syntax and semantic meaning of the table will be written into the lexicon. The post tagger class shows the training process of the tagger model. It basically shows the training of the model that tags a token with its semantic type. Here I have trained a unigram tagger by determining label dictionary information as a parameter by initializing the tagger. The training process includes assessing the tag of each word and storing the training data inside the pickle file. The SQL Mapper class shows the implementation of the Mapper model. This code shows training of a model that tags a token with its SQL syntax and finally stored in a pickle file as described in the previous class. Now you can see the final output of the generated singular lexicon file and the metadata process file. Now let's move on to the query generator class, and this generate boundary command is a method which is searching the index of the boundary and the command tokens in the normalized query. The boundary tokens list will iterate in order to search an index for the boundary token from the normalized token list. Then the max value from the boundary index dictionary will assign as a boundary index and gets the index of the normalized token by returning the value of the item with the specified key in the tag dictionary. Mainly, when defining the conditional part of a sentence, two possible types were identified. The conditional part can be excited in the beginning of the sentence or at the end of the sentence. According to the types of sentence, boundary token similar to samana, vana, pamana, vada, adu. Initially, the system will search for the boundary token, and if it found a boundary token, the sentence will be separated into the conditional part and the main part. And the sentence will be separated into two parts, like the conditional and main from the splitting point where the boundary token has found. However, to split the conditional part, which is at the end of the sentence, was implemented according to the different scenario. For that kind of scenario, we'll be first search for a boundary token. If the sentence includes such a token, then the system will split the sentence from the command token of the query. This is the database table I am using for the demonstration. Now I am move on to the demonstration of SQL Finder. I have distributed a Google form in order to collect single natural language sentences from the end users of the system. This is my single natural language interface for databases web page. User can write the input inside this text field and also click this button in order to generate a SQL query. This is the text area which shows the generate query. User can modify the generated query if it is needed. And also user can click this button to generate results and enter the next single natural language query to generate the SQL query. Here I have entered an example and click this button to generate SQL query. The query has created successfully. Here the word Arwange has identified as a synonym to the Sisua, and it refers to the student table. Now let's see the second example of generating a fundamental query. If no column is found in user input, then we set the column as all type. All the columns will be selected as a result. This example shows identification of greater than or equal function.
Thank you, Dunisha. Are there any questions from the participants? Are there any questions? Okay, it seems there are no questions. I have some questions. So, though you have mentioned some future work in the paper regarding extending the SQL Finder, SqL Finder, your current natural language interface seems to be at the prototype level, and also Sinhala lexicon database, the database was created manually. So are you planning to extend this work to a particular domain? For example, like academic domain, bioinformatics or medical domain, and allowing the system to generate the Sinhala lexicon automatically, and also finally make the prototype as an executable one?
Yes, Miss. First, I have to analyze the structure of the sentence because this support for only the selection and deletion type of queries. And I have to expand the lexicon if I use this for another domain.
Okay, I think if you narrow down the scope of the test domain, you can do this.
Yeah.
You can come up with a good executable one, right?
Yeah.
So there's another question regarding your results. Did you compare the results with other state-of-the-art research in other languages than Sinhala?
No, the research is mainly focused only for the Sinhala language.
Okay, thank you, Dunisha.
Thank you, Miss.
On to the next presentation. The paper ID is 153 and the title is Navigate Me, Secure Voice on Authenticated Indoor Navigation System for Blind Individuals. And this paper has been authored by Disanayaka DMLV, Rajapaksha RG MDRP, and Prabhashwara UP, and Solanga SAD SP, and JADC Anuradha Jayakodi. This work is presented by Rajapaksha, who is the final year undergraduate student in the Sri Lanka Institute of Information Technology, Malambe. And over to you, Rajapaksha.
Hi, good morning everyone. Our research is Navigate Me, a secure voice authenticated indoor navigation system for blind individuals. In this research paper, we are discussing about a voice authenticated indoor navigation system built targeting the blind individuals. Our group members are Disanayaka DMLV, Rajapaksha RG MDRP, Solanga SADSP, Prabhashara UP, and Dr. Anuradha Jayakodi as our supervisor. In this presentation, we will be going through background, introduction, objectives, methodology and implementation, result and key findings, and references within this short time period. According to this graph, blind or visual impaired population increases 1 to 2 million in every year, which indicates there is a considerable amount of people adding into the list who need support in moving inside an indoor area. Unlike the outdoor navigation, when it comes to indoor navigation, the accuracy of most of existing technologies are low, and it's challenging because of the obstructions like walls and other furniture available inside the building. And also in the current scenarios, blind individuals have to seek help from an outsider in order to reach their destination, which inputs themselves in vulnerable situations. Also, most of the common technologies like GPS are not effective in Indo areas. So the Indo navigations, which has been built using such technologies, has a huge inaccuracy in Indo navigation. Most of the available technologies are not affordable when considering their income of the people in developing countries like Sri Lanka. So such solutions built with high-end technologies and not practically afford for the target audience. Also, during our literature survey, we identified that though there are currently indoor navigation solution available, most of them are not not developed targeting blind or visually impaired people. So there were accessibility and usability issues in these systems. Uh, so addressing the problems existing in these current situations, uh, Navigate Me was developed mainly targeting the visual impaired people, focusing on the usability and accessibility, enabling them to reach their destination inside a complex building without seeking anyone else's help. To increase the accessibility, we have implemented voice control in the mobile application to application so that the user does not need to use touch screen, and he or she can use voice commands to control the application. uh, Practically, there can be background noises of other people on the pathway, same as the Navigate Me user, and in order to prevent problems which may occur because of that, we have implemented voice recognition as well using machine learning algorithm. With that. It is ensured that the application won't perform on behalf of other voice generated in the background. Not only data input, output commands also voice based in Navigate Me, so that user can easier recognize the directions he or she needs to direct. Furthermore, user can easily identify the obstacle on pathway using the Navigate Me smart stick, and based on information extracted from the smart stick, other users are also warned not to use obstructed path, so that they can use optional path to direct to the location. Our primary objectives of Navigate Me is to provide a voice controlled and voice authenticated indoor navigation system, mainly uh, vi- targeting visually impaired individuals to navigate inside in an indoor environment. So let us discuss about our methodology specific to our system. To achieve our objective of the research, we explore the current solution during literature survey and analyze the available technologies suitable to our solution, considering facts like accuracy, coverage, cost, and complexity of it. And for the assistance of development, we divided the solution into subcomponents like localization, path detection, voice authentication and voice control, mobile app development, and also obstacle detection. Uh, as a result, we were able to complete the localization using Bluetooth beacon via Bluetooth technology. As Bluetooth technology is readily available in the most all the latest smartphones, the user do not need to go through any troubles in adapting themselves to technologies used in navigating. The beacons are identified uniquely with UUIDs, and the distance is calculated by RSSI values. The accuracy of the distance in localization is 0.1 meter. And to identify the best possible shortest path, we used a star algorithm because of its less complexity. Uh, Here in this slide, these are two screenshots we have taken from the mobile application, our mobile application. In the first slide, use is at a node, and the user input the location as b node via voice command. With the help of a star algorithm, the system calculates the shortest possible path and outputs the direction to navigate to B node successfully. According to the test result, output results has more than 90% accuracy. The most significant item of the Navigate Me is the voice authentication. So far, voice recognition of the user, we use uh, recurrent neutral network algorithm. To train the model, we had to feed the algorithm with user's voice, non-user voices, and also background noises. After training the algorithm, it identifies the user voice and outputs a binary result like user or non-user based on the confidence level of the input voice. With time based on the data feed, it gives more accurate output. This is a graphical view of the test result using the user's voice recognized by the machine learning algorithm when user was using different frequencies of voices as input command. This is a graphical view of test results when we used non-user voice as inputs, and the test result, how the machine learning algorithm identified them as non-user voices. With this chart, it is obvious that the used machine learning algorithm is not giving 100% accurate result, yet it gives around 92% accurate result as output, which is sufficient percentage. And finally, in order to give maximum security and usability to the user, we build a smart stick which has connectivity between the mobile app and the server to update any blockers in the map if there is a blocking obstacle on the pathway in front of the user. Using this smart stick, user can recognize the objects ahead with the alert sound emitting by smart stick if there are any obstacle nearby. This solution increases the safety of visually impaired people as they no longer need to rely on strangers to get the direction to a location in a indoor area. Though the main target audience is visually impaired people, this application can be used by fully sighted people as well. Moreover, this solution is more convenient for the COVID-19 situations as well, because with this application we can reduce human contact by reducing the need of communication in wayfinding. So we have come to the end of our presentation. Thank you very much for your time, and you are more than welcome to raise any question regarding our study. Thank you.
Thank you for your presentation. Now we'll be moving to the Q&A session. Does anyone have any thoughts, any questions? Any questions from the audience? I'm the only one asking questions. It seems there are no questions. I have some questions. Actually, I heard that you manually set up beacons. So how do you measure the lighting condition to find the dark spots?
Madam, it is not consider the lighting conditions. It's receiving signals it's emitting signals, and we receive signals by the smartphone. It's not the lighting condition. It's not considered for our method to our technology.
And also, what kind of algorithms and techniques that you use to enhance the security of the system? Actually, you said you use some data encryption. Is that the only way that you address your security risks in your system? I mean, between the server and the application?
We have used normal encryption method to encrypt the data connection between server and application. And
algorithm or the method?
We use normal encryption and MD5 like thing. For main security part is that voice authentication part.
Okay, only that thing. There are so many security risks we have to consider when we develop this kind of an application.
Yeah.
So you have to consider other risks as well. Okay. Okay. Thank you.
Okay. Thank you.
Thank you.
The next presentation is paper ID 18 on hate speech detection in Sinhala English code mixed language, which is authored by Oshadi Lianage and Krishna Kripa Jayakumar. The research work is presented by Oshadi Lianage, who is a student at Informatics Institute of Technology. So let's listen to their work.
I am Oshadi Gandhika. I am a student at the Informatic Institute of Technology, and my supervisor is Ms. Krishna Kripa Jayakumar. Our research is hate speech detection in Sinhala English code mixed language. This is the agenda for the presentation. There are about 10.10 million internet users in Sri Lanka, and it's nearly 47% of the population of our country. Social media related cybercrimes has increased twice than the cybercrimes reported in 2019. Hate speech is a type of cyberbullying which is defined as any communication that attacks a person or group of people based on the characteristics of them, such as sex, gender, location, skin color. Hate speech causes negative impact on both bullies and victims' mental health, and it can lead to the depression as well. In worse scenarios, it can lead to suicide as well. In social media and other websites, users need to manually report the hate content and service providers need to manually review them and remove them. It is very time consuming and it is not effective since service providers don't have good understanding on low resource languages like Sinhala. In 2018, after the Sinhala and Muslim riots, and in 2019, after the East attacks, Sri Lankan government had to restrict access to the social media sites to stop spreading hate speeches online. Facebook announced that they couldn't remove the hate content because of the unavailability of the reviewers who know Sinhala language. In recently, all the Sri Lankans were banned from an American Fox News journalistics Facebook account due to the hate comments written in Sinhala language because of an abused Sinhala word similar to her name. From all the above mentioned incident, it is proven that hate speech detection in Sinhala language is an important task. Sinhala native speakers use Singlish language when they are expressing their feelings on the internet. Singlish is a blend of Sinhala and English language in which Sinhala words are written in English alphabetical characters based on their pronunciation. These are the example comments I have taken from the internet. Now we will move to the existing research works related to Sinhala hate speech detection. In 2018, Mr. Dias and others conducted research on identifying racist social media comments and they used SVM as their algorithm. From the experiments, they have identified that their model only works well in small data sets. In 2019, Mr. Sandharwan and others conducted research on hate speech detection in Sinhala and they experimented machine learning approach, corpus-based approach and dictionary-based approach. From the experiments, they have identified that machine learning-based approach works well in single hate speech detection. And they have identified character n-gram performs well in hate speech detection. In 2020, Ms. Ishara Amali and Mr. Jailar conducted the research on classification of cyberbullying Sinhala comments and they used SVM as their classification algorithm. In all above mentioned research works, authors have identified that there is a research gap on identifying hate speech comments written in Singlish language. From my research, I contributed to fill that research gap. There is one research work focused on hate speech detection in Singlish language. It was conducted by Ms. Hetty Arache and others in 2020. They evaluated 4 machine learning algorithms, namely logistic regression, support vector machine, multinomial naive Bayes, and random forest classifier. They used TF-IDF vectorizer and count vectorizer for vectorization and they used word n-gram features. They have for their research, TF-IDF vectorizer works well with word bigram features. From the machine learning algorithms, multinomial naive Bayes algorithm worked well in their research. My research aim is to research, design, develop, and evaluate a system that can detect hateful posts written in Singlish language using machine learning techniques. This is the process I followed in my research work. First, I constructed the data set since there is no publicly available data set for Singlish hate speech detection. I gathered comments from YouTube and Facebook. YouTube API was used to collect comments from YouTube and comments were manually scraped from Facebook. Comments were queried using the keywords related to riots, games, famous people, and ongoing incidents. Only the comments from public posts were considered and only the comment was collected without collecting users' data to ensure user privacy. Then Singlish comments were filtered. All the comments were annotated by 3 annotators who have good knowledge on Sinhala language. And intention of the comment were considered without using the keyword spotting techniques when annotating the data set. Nearly 53% of the data set is hate comments and 47% of the data set is non-hate comments. Inter-rater reliability of the data set is 86.65. Removal of numbers, special characters, accented characters, URLs, and emojis were followed as reprocessing steps, and converting text into lowercase tokenization and removing HTML characters also followed. When it comes to stop word removal, an experiment is also conducted. As the results, it has shown that there's around 1% of accuracy improvement without the stop words and pronouns removal, due to the fact that stop words removal is not considered as a preprocessing step. I use DFIDF vectorizer and character engrams as the features. I did several experiments with character engram and word engram features, and from that experiments, I identified that character engrams up to 5 grams works well in hate speech detection in English language. After the feature extraction, I evaluated the performance of 8 machine learning classifiers, namely logistic regression, support vector machine, multinomial naive Bayes, KNN, ADA boost classifier, decision tree classifier, perceptron classifier, and Bernoulli naive Bayes classifier. From the mentioned classifiers, I selected top 4 performing classifiers and developed hard voting ensemble approach, soft voting ensemble approach, and stacking ensemble approach, and evaluated their performance as well. Best parameters for each model were identified by hyperparameter tuning using randomized search CV with 5-fold cross-validation. Every algorithm were trained using 70% of the data set and tested using 30% of the data set. Multinomial naive Bayes, support vector machine, ADA boost classifier, and logistic regression classifier were used to develop ensemble approaches. In stacking approach, support vector machine, multinomial naive Bayes, and ADA boost classifiers are used as based learners, and logistic regression classifier is used as the meta learner. All the classifiers were evaluated based on accuracy, F1 score, recall, and precision values. These are the results obtained when character engram and TF-IDF were used. From these results, it was identified that hard voting classifier works well in hate speech detection in English language. Now we will move to the contribution of the research part. Created data set for this study will be available for the use of future NLP research. 8 machine learning algorithms and 3 ensemble approaches are evaluated in this study, and out of the evaluated 8 machine learning algorithms, 5 of them have not been explored in the published research work in hate speech detection in English domain. Both character and word engram features have been explored in this study, and only word engram features were explored in existing works of the domain. Now we will move to the future enhancements of the research. Performance of the model can be enhanced by increasing the number of records in the dataset. And with the large datasets, deep learning approaches can be utilized. We will extend our research to classify the comments into hate speech categories in future. Thank you.
presentation, Oshadi. Now we'll be moving to the Q&A session. Do you have any questions?
What is the size of the data set? So
Oshadi.
what is the size of the data set? Hello,
Hello.
can you hear me?
Hello.
Yeah, what is the size of the data set?
It's nearly 1,400 records.
Mhm. So it's 50-50. What is the percentage from each class?
Here, hate speech class contains nearly 53% of the data set, and non-hate speech class contains nearly 47% of the data set.
Why you select 5 grams?
So I did several experiments up to 5 grams because the published research works, existing works only considered about the word n-grams, and I did experiments on word n-grams and character n-grams.
Okay.
I mean, bigram or trigram. So far, what is the size of the n-gram more like? You use 5 n-grams or the word gram or character based n-gram?
So I did experiments with both word n-gram and character n-gram features up to 5 grams. Like
so you select the best one.
Yeah, character n-grams outperformed.
So have you used a lexicon, the vocabulary for the hate speech words? No.
No.
Okay. I have questions as well. You have obtained higher accuracy with character n-grams than word n-grams, right? So can you justify that?
Character n-grams works well with the text that are common with misspellings.
So is that the only reason? Is that the only reason? Okay, you think that is the reason, right? So, and I saw that you have used 8 models for evaluation. Is there any specific reason for that selection?
Miss, I referred the existing works regarding to hate speech detection in code mix language, and I selected those algorithms from the literature review. And those algorithms have performed well in existing research works in other languages.
Okay, that's good. And also I think that you have missed the evaluation with the state-of-the-art methods. So did you compare your work with state-of-the-art research work? That means not only in Sinhala, but for other languages like Chinese, Japanese, or other code mix languages?
No, Miss, there's only one research work published on hate speech detection in English domain before. In their research, they have used multinomial naive. For their research, multinomial naive-based algorithm worked well, but
Bayes method.
Sorry,
Multinomial. I can't hear that. What's the method?
Multinomial naive-based algorithm. I also evaluated multinomial naive-based algorithm, but hard voting classifier outperformed that algorithm in my research.
I think, but there are research out there for other languages like Chinese, Japanese, right?
Yeah.
So you can compare your work with that.
Yeah. Okay.
And So I think you can improve your work by increasing the number of data, as you said, and you can use deep learning techniques for the research as well. And also you can use collect data from many social media like Facebook, YouTube, or Twitter, right? So, okay, thank you very much.
Thank you, madam.
Our next presentation is the paper ID 159, and it is on an ontology-based question answering system for computer network module. And this has been authored by MIM Naushad and Samantha Rajapaksha. The presenter is MIM Naushad, who is a postgraduate student pursuing MSc in IT at Sri Lanka Institute of Information Technology and has completed the first degree in computer science at Savaragama University of Sri Lanka. So let us present the research work of Naushad and Samantha.
Hello everyone, welcome to my presentation. My name is Naushad and my co-author is Samantha Rajapaksha. This is the paper ID 159, an ontology-driven question answering system for computer network module. Introduction. Question answering is a branch of AI within the natural language processing and information retrieval field. It building a system that answer questions that are posted in natural languages by the users. Then we look at some background studies. An ontology-driven question answering system for legal document, which is published in 2019 in India. They have developed ontology-driven question answering for motor vehicle department. It defines a set of offenses and related penalties. They have used semantic role labeling to identify the roles of each word in the offense. Also, they have used ontology to create use as the medium for question answering. Finally, they have developed a system which is extracted domain-specific terms with minimum human intervention. Another research paper called Design of Ontology-Based Question Answering System for Incomplete Sentences, which is published in 2019 in Indonesia. They have designed an ontology-based question answering system that's capable for dealing incomplete question sentence. They have used two approaches. One is design an ontology that used keyword property to find the question objective. The second one, design an architecture that transforms the question in natural language into instruction that can be understood by the machines. Then the test case were conducted on 3 groups of question sentences. One complete question sentence and incomplete question sentence also can be tested, and keywords also tested. There's another research paper, a domain-specific ontology-based question answering system, which is published in 2016. They have aimed to develop an automatic query generation for natural language questions, thereby developing a domain-specific natural language question answering system for ontology. The accuracy of the system is improved by using the DBpedia ontology for extracting some sort of information about the domain. They focus on the domain of news events of new appointments in various organizations. Finally, they have developed a QA system for the domain of news events of new appointments in various organizations. The other one, an agriculture domain question answering system using the ontologies, which is also published in 2019. They have developed a QA system on agriculture domain. They have used techniques in natural language processing and semantic web technologies. They have developed a prototype in Java, and the basic information about agriculture is collected and fetched. The questions are tested by the system in many forms. However, in every time it returns the same answer. This proposed system aims to design and develop a question answering system for computer network module with the help of ontology, and also to provide precise answer for user question quickly. This project also aims to ensure that the answers provided by the system are identical to the answers the user is looking for. This research project tried to find out the following research questions answer. How the proposed QA model helps IT students to get the exact answer to their user queries. What are the real benefits of this proposed QA system, and how this particular QA system differs from the existing QA system. Then we need to look at the architecture of the QA systems. This is the general architecture of any question answering system. Question, when enter the question, it goes through this kind of pipeline, like question analysis, document analysis and retrieval, and answer analysis. Finally, it returns the answer. And this is the ontology-based architecture, where each component of the question answering system is linked to ontology. And this diagram shows our proposed architecture, where user enter the question through the user interface and get the answer. And we have used ontology and the web-based to get the answer, and other components remain same as the previous system. Then the QA system process, in general, they have three components: question analysis, document processing, and answer processing. Question processing has subcomponents of tokenization, stop word removal, type of the question needs to be identified, and stemming, and part of speech tagging. Under the document processing, we need to establish the ontology or RDF store and ontological dictionary. Finally, we have to maintain the knowledge base. And the answer processing, we need to retrieve the answer from the source that we have developed for this particular question answering system. This table shows how the question analysis phase carried out. Question words whose mainly focus on the person, whereas the where it asking in or what place or position, so it returns location. This Python program shows how question analysis will take place in question answering system development process. This particular research have minor innovation or novelty. That is, the user have multiple options for getting the answer from the ontology or from the web-based system. And this existing knowledge is going to apply in new domain. It is ICT subject, computer networking. First, we have used web-based QA system. Here we used Google and Wikipedia search engines to get the answer. We are not get all the answers, but using the filters we use, first 3 results are returned as an answer. When we enter the question using this web interface, we get the answer. Then we have to develop an ontology-based question answering system. To do that, we need a data set. So computer network module information or the data can be obtained from the website of the National Institute of Education by accessing their official website www.nie.lk and the following 2 links. We have used a couple of packages and tools to build the ontology. Protege 5.0 software we have used to create the ontology, and Python is the programming languages, and some Python packages like NLTK. It is very useful to do the pre-processing of the question, and TK Inter. It is a standard GUI library for Python, and already too, it is a package for ontology-oriented programming in Python, and Flask to build a web application like that. Then we need to build the ontology. So there are classes, the concept of the ontology and type of the ontology. Then we have to build we have to create individuals. Individuals are the specific instances of the concept, and the concept can be described more clearly by the set of common attributes that can be called properties. There are 2 properties, data property and object property, that can be discussed in the following slides. And the relation, it describes the interaction between concept or a concept properties. For an example, subclass of or is an exit. This is the class hierarchy of the proposed system. A computer network is the subclass of thing, and protocol, IP address, basic, reference model, topologies, security concern, and network devices. Those are the subclasses of the computer network. And this picture shows the complete class hierarchy. For an example, a reference model, it has another 2 subclasses called TCP/IP model and OSI reference model. Each reference model has its subclasses. For an example, OSI reference model has 7 layers, and these 7 layers are the subset of or subclass of the OSI model. Then the object property is used to connect 2 classes or 2 instances. For an example, IP address and network devices are 2 classes in this class diagram. So these 2 classes are connected using assign to object property. Like that, data property is used to create a relation to a class with literal. Here we have to define the domain and the range. Now we have both system called web-based system and ontology-based QA system. So we need to compare the performance between these 2 question answering system. For that, we need to have some sort of performance parameters. accuracy, precision, recall, and F measures. Accuracy is measured as a percentage, whereas the other three components lies in between 0 and 1. 0 is the minimum value, whereas the 1 is the high value. The optimum value can be greater than 0.7. In both systems, we have tested with 45 sample questions. Same 45 questions are fed into both systems, and the answers are recorded. Web-based QA system results are shown in this table, whereas ontology-based QA system results shown in this table. These results can be computed the performance indicators based on the results obtained and compare these two systems according to that results. Accuracy 38% in web-based QA system, whereas 87% of accuracy for ontology-based QA system, and other three factors having 0.93 for ontology-based QA system and web-based system have lower performance indicators compared to the ontology-based system. These figures can be graphically shown in this diagram. Finally, the conclusion. Using the results, we can come to conclusion like ontology-based QA system returns better responses to the user queries than the web-based system. Also, the ontology-based question answering systems giving quick response compared to the web-based system, because web-based system need to search a lot of web pages unlike the ontology-based system. And the end user can easily recognize and identify the difference between both system answers. These are some recommendations. This ontology can be extended to accommodate other computer modules like operating system, database management system, and data communication, and so on. So the user can get more subject to test and get the answers. Also, the ontology-based QA system can be implemented in other local languages like Tamil or Sinhala language. And also, this question answering model can be implemented or incorporated with some machine language algorithm to improve its efficiency and usage across multiple dynamic knowledge bases. These are some references that we have gone through to do this research and prepare this presentation slides. Thank you.
Thank you very much, Naushad. And are there any questions from the participants?
Yeah, I have one question. So you mentioned about this NIE site, and you showed that that one has a web-based system, and I saw 2 grade 10 and 11 textbooks there. How you calculate the accuracy of Q&A session in that one? Can you more further elaborate that one?
Yes, I have used a data set from the grade 12 ICT textbook.
That is a PDF file, 2 PDF files I saw.
Yeah, they have PDF files, but website we can download the teacher's guide like that.
Yeah.
It's from teacher's
So
guide.
now that is your web-based system.
For both.
Yeah, no, I mean, how you calculate the accuracy of a web-based?
Accuracy, sir, I have used 45 sample question to feed both system, like what is networking or what is the objective. So I get the results and recorded. Then using the equation, calculate the accuracy, sir.
So you have one PDF file, two PDF files there.
Mhm.
How you ask the question from there and get the answer? That is just a file.
It's
So
just the
all
file for the
all
data set. I have developed a web interface to ask the question. User can enter the user queries in that website.
Yeah, in every case, if the answer is in that book, the entire book will come as a search result in the web-based system.
In the web-based system, we use Google search and Wikipedia codings for in Python. It takes from the answer from that website, and ontology we build using that textbook.
Yeah, so ontology you build from that book,
Mhm.
and this the whatever you answers get from the web is different from different website, different results you get for the same question.
Yeah.
So how you compare those results and your results you created using your the two textbooks and you with your ontology based the environment, and you get direct answer from there because you converted the knowledge in the two textbook into knowledge base there. You own knowledge based on those aspects about networking. But this web is a very open one, so you will get many query result and with different ranking. So how you compare those two things to say that this is a low accuracy and this is high accuracy?
That is comparing this web-based system normally when we use the web, but the results we get and compare with our system like that.
Okay, I have some questions there. Yeah, that's all from me.
Okay, thank you, sir. Are there any other questions?
Sugandhima, we cannot hear you.
Sorry. Are there any other questions?
This is Mudita. I have a small query, few clarifications. Can I know how did you construct the ontology? That means is it a manual approach or kind of automated or semi-automated approach?
It's a manual approach.
Manual approach. So
because
then,
we have the learning objective and sub-learning objective. All learning objective take as a class like that.
okay,
Manually.
Right. Okay. That's the best method actually when you do a kind of a domain specific ontology, you have to follow. That is the most, you can use kind of semi-automated one, but the accuracy may be lower. But if you have used manual approach, I think you can achieve a good accuracy. And also I want to know when you constructed the ontology, how many axioms were there? Did you count it?
Actually, I didn't, but
you didn't count?
No, I didn't.
How many classes were there?
It's more than 52 classes.
52. Right.
All
class. Yeah, your ontology is based on RDF, and when I listened to your presentation, what I understood is the most challenging part is converting the natural language question into SparkQL query. So that is the most difficult part in a Q&A system. The user present the question in natural language like English, and in your methodology, you convert that into SparkQL query, right? So it is the most challenging one. So did you check the accuracy of that part? because all depends on that. If your query is correctly converted into SPARQL query, then only you can get the accurate results from the ontology. Otherwise, ontology will not reason out the correct answer.
Yes, Miss. What I did when after construct the ontology, I upload that ontology file into the Apache Jena Fusuki server. Then I write the code there. Yeah.
Right.
So I write the code in that query mode, then get the result. So that is the
Then
query.
that is just you created the SPARQL queries.
Yes.
Then for the kind of a system, you can't use that, no. So you have to automate that part. So when you do that, if you haven't done that, done your project into that level, my suggestion is to concentrate more on that. Thank you very much.
Okay, Miss. Thank you.
Okay, thank you. I think I have one more question as well. Actually, you have mentioned that searching to the question answering system is more efficient than the normal system. So why did you compare the speed up of two methods? I mean this performance speed up.
Speed up, yeah. When we type the web base, it takes few more time. I mean, not measure manually with the timer. Just we can observe the difference when load the give the answer. Yeah.
Yeah, I believe that if you include that in the paper, or if you extend the research, you can do that part as well with different sizes, sample sizes.
Okay.
So, thank you very much.
Thank you, Miss. Thank you.
Now we have come to the last item. It is a poster presentation, and it is on Smart Digital Personal Fitness Trainer. This poster has been authored by Chamodi Lokuge, Chanit Gamage, and Yukti Lochana. This poster is going to be presented by Chamodi Lokuge, who is from the Faculty of Information Technology, University of Moratuwa. So let's listen to her presentation.
Before moving into the research presentation, I would like to ask you a question. Did anyone of you ever thought of being healthy and staying fit once in a while? Or did you ever thought that it would be nice to have a personal fitness trainer to guide you on your fitness journey? The answer might be yes, but we all know that personal fitness is an expensive commodity which most people who are into working out are not privileged with. So the goal of this research is to implement a low-cost digital fitness trainer to smartly mimic a qualified professional fitness trainer. I'm Chamodi Lokuge from University of Moratuwa. My colleagues are Janit Gamage and Yukti Lochana, and the project was supervised by Dr. Upeksha Ganegoda. So essentially, we identified three major areas related to personal fitness training and implement them as three modules. These three modules are post-estimation module, safety module, and the personalized meal recommendation module. Post-estimation module helps users to maintain a healthy and safe pose while exercising. This module analyzes the user's workout videos and outputs the number of repetitions performed. This also identifies the deviations of the user's pose from the ideal pose and gives visual pose correction recommendations. For example, if the user is performing a squat incorrectly, the module identifies the deviations and suggests corrective recommendations. This module uses Python, OpenPose library, loss filtering, and dynamic time warping. Then we have safety module. This helps users to safely perform exercises while maintaining a safe heart rate and avoiding overexertion and straining on body parts. This uses long short-term memory neural network which accepts the type of exercise, exercise frequency, and the exercise time period. The resting heart rate is obtained from a wearable device, in our case an MI band. We are using a React Native app to get the user inputs, and with the trained model, the app visualizes the predicted heart rate variations of the exercise the user is about to perform based on the user inputs, the preferred exercise frequency, exercise intensity, and the exercise time period. Then we have personalized meal plan recommendation module. This module aims at delivering a fine-grained, personalized meal plans that please the user taste while adhering to the nutritional guidelines. This uses a content-based recommender system with a fine-tuned LDA model to output the personalized recommendations based on the user-preferred meals we get as user inputs. This calculates the user's caloric needs in correspondence to their BMR and the goal weight. Then the daily calorie allowance is translated into an actual meal plan. And we also ensure that macronutrient, that is carbohydrate, protein, fat, requirements of the user is also satisfied. So with our low-cost solution, we could help the users to achieve their fitness goals. Thank you.
Thank you. Now we can move on to the Q&A session. Are there any questions from the audience? Are there any questions? Okay, it seems there are no questions. So I have a simple question for you. Actually, I am not clear about the data set that you have used in post estimation. Is that using a selected set of data from that open post library? Hello, can you hear me?
Yes, we can. Is the post presenter there? Maybe they are not present in that.
Shamodi, are you there? I think she's not here, right? Is there any other author here? Okay, it seems they are not here in the session. So we have come to the end of the NLP session. So thank you very much for being here. Is Shamodi here? Okay. Okay, I think she's not here, right? So thank you very much for being here till the end. And now it's time to wind up the session. So over to you, Shavindra.
Thank you very much, Dr. Vidaran. Yeah. So on behalf of PCSC, I would like to thank you for leading the session, and also for all the authors, I would like to thank them as well. So the session 4B is now over. The next session in our agenda is the keynote 6, making smart speech more playable by Professor Anton Malta. So I hope you guys join that session in the main Zoom window. Thank you very much.